Hi, it's Valentine from Simplistic, and today we're going to take a look at a problem where we have a weak acid solution, which is 0.175 molar, and the pH of the solution is given to us, and from this we have to determine the Ka for the acid. So the way to do this is you have to set up let's go ahead and set up the equilibrium first, and then create an ice table, and then take it from there. So let's assume that the acid is HA. Let's call that HA. So HA is the acid. We're going to draw out the equilibrium for the acid. So the acid dissociates, or rather ionizes, to form H plus and A minus. Okay, once we have that, initially what is given to us is 0.175, and we have 0 and 0. The change is going to be 0.175 minus X, because that's how much dissociates. We're going to have X and X of H plus and A minus forming. And then at equilibrium, we're going to have 0.175 minus X. And then we're going to have X and X. Okay, so Ka, the acid ionization constant for the weak acid, is given by concentration of H plus times the concentration of A minus over concentration of the acid. So what we're going to do is we're just going to replace these with this, and this. So that's going to give us X times X over 0.175 minus X. And we have to solve for Ka, but before we can solve for Ka, we have some other information given to us which will allow us to figure out what is X. So what's given to us is the pH, okay? So it turns out, I'll write that out here, when pH is given to us, then you can solve for the H plus ion concentration by taking 10 raised to negative pH. All right, so if we do that out here, since the pH is 3.25, so the H plus ion concentration, which is the same as X, is equal to 10 raised to negative pH, which is negative 3.25, and that gives us 0.0000562. Okay, so once we have this expression, we can just plug this in here. So that's going to give us 0.000562 square over 0.175 minus 0.000562. Now if you pay close attention to the bottom out here, you can see that this is so small because there's only 3 decimal places, and out here the first digit is after the third decimal place. So therefore, for all intents and purposes, this can be neglected from the bottom. So this entire thing can simplify to 1.8 times 10 to the negative 6. That's it. That is the value. Oh, I'm sorry. We're putting this is in this, so therefore when we solve for, this whole thing gets simplified, we get the value of Ka, which is what we're trying to solve for. So this is the value of Ka for this weak acid solution. I hope that made sense. Thank you for watching.